Okay, let's give you guys some more practice. So given a function f of x equals sine of x here, figure out if this function here is an even function, an odd function, or neither. So when given this function here, just roughly sketch it so that you get a rough idea of what's going on inside your mind. So sine of x will look like this, 360. You could extend it again, or you could extend it into the negative realm. So it's negative 360 over here. So in this you could do it algebraically, or you could just draw a rough graph and then reflect it along the y-axis to see if the reflection is equal to the original function, or well, do whatever you want. Figure out if it's an even function or an odd function. Okay, so press pause and have a go. Okay, so let's start by just roughly sketching this function here. 360 here, extend it over here. It will be negative 360. Okay, and then now looking at this, let's apply this transformation. Applying this transformation would mean we are in a way reflecting it along the y-axis. So when you reflect it, looking at this lump here only. When you reflect it along the y-axis, the lump would be here. So it's like it's like this here. Now remember, this in order for this function to be even, this whole equation has to be satisfied. Meaning that the reflection here, this is a reflection. The reflection is exactly the same as the original function. You can see that looking at this lump here. When you reflect it, it looks like this. And this thing here is not exactly the same as the original function. So it's not, this is the original function here. It doesn't, yeah, it's not exactly the same as the original function. So now we know that this is not an even function. So now let's start again. Let's check if it's an odd function. So start by sketching our, just a rough sketch we'll do. 360 here, and then negative 360, negative 360. Okay, so looking at this here, you have a choice of reflecting it, so everything gets reflected this way, and then on a separate occasion reflecting it along the x-axis. So this will move up here, and then will this be exactly the same as this? But rather than visualizing this and then this, I'm just going to visualize it as a rotation. So remember, it's the same thing. You executing this and executing this is the same as you rotating it 180 about the origin. So now I'm just going to I could do this and then do this and then check if the two are the same, or you could just do a rotation. It would be the same thing. So here 360. I'm going to so this is negative 360. I'm going to somehow rotate this 360. So I'm going to rotate this 180. Okay. Oops. Yeah, rotate it 180, not 360. Sorry. If you rotate it 180, that's the equivalent of you executing this and checking if these two are the same. So rather than checking these two are the same, we're going to rotate it 180. So here, looking at this only, looking at this lump only, when you rotate 90, this is the height here. When you rotate 90, this will be the height here. So the lump here will look like this when you rotate 90 degrees. Now, so this is the height at the moment. When you rotate it another 90, which will give you 180, this here's the height here. In a way, so the height is here. Now it's here. So the lump will be down here. So this lump here will look like this. Okay. Now looking at this lump here, when you rotate it 90, it will be right here. Okay. Now when you rotate it another 90, hang on. Currently it's here. The line is here. When you rotate it 90, the line will be here, giving you this lump here. So you can see when you rotate it by 180, it does match up with the original original function. So it also works if you keep on going. If it's like this, one period, 2, 3, it does still work. If you rotate the whole thing 180, it will match up with the original function. Okay, so therefore you know that this here is an odd function. Or another way of doing it is to stuff this -8. Is to stuff this negative x here into this x here. But basically execute this transformation here, put this -x into here, and then see if it equals the original function. So if you put this -x into here, so your transformation here, when you apply this transformation here, it will be this sine -x. Now the question is sine -x equal this? How can we be sure? How can we be sure that this is exactly the same as this? Okay, it boils down, is sine of -x equal to sine of x? So you really have to investigate for yourself, because if you just start by sketching sine of x here, okay. Now when you look at, let's say, sine of 90, so 90 is like your standard normal x as opposed to negative x. So sine of 90, well, 360 is here, 180 is here, so this is 90. You can see sine of 90 is 1. Okay, now come to this bit here. When you look at sine of -90, okay, so that this will be, well, this is -360, -180, so -90 is here, negative of 90. So you doing this is you getting this value here, getting this, getting the value of sine of -90. So that's negative. Well, my point is that, hang on, you see, at the moment sine of 90 equals 1. Okay, sine of -90 equals -1. So at the moment we can speculate. We don't know for sure, but we can speculate that sine of 90 is equal to minus sine of 90 here. Okay? Sorry, hang on. Sine of -90, we can speculate that you can just do it as a sine of 90 normally, and then stick a minus in front of it. We can only speculate at the moment, because looking at this, when you look at sine of -90 here, that's well, sine of 90 is 1, and then sine of -90 is -1 down here. So we can speculate that, okay, when you come to do sine of -90, that's like you finding out sine of 90, and then it will be the negative version of sine of 90. So we can only speculate at the moment. Okay, now let's look at a different point. So here, so let's look at 180. So sine of 180 is 0. You can see here. Now let's look at sine of -180, sine of -180. Well, that's like you finding out sine of that. Well, sine of -180 is here. That's the same as sine of 180, the normal sine 180, which is 0. And then even if you put a negative in there, it will still be 0. Okay, let's look at a different point. Let's look at this is 360, 180 here. So this point here is 270. So let's look at sine 270. Okay, so sine of 270. So sine of 270 is -1. Okay, so this whole thing here is -1. Now looking at sine of -270, that's like you finding, well, that's like you doing this 270, and then that's it seems to match up with this one. So at the moment we can speculate that sine of minus x equals negative sine of x. So this is this should be inside your mind, but we don't know for sure yet. Okay, we know that roughly it is rough. We think it's the same thing. Okay, my point here is that you can still use this, put it into here, so it will give you sine of negative x here, and then from what we gathered, you can say that this equals minus sine of x here. Okay, and look at this here. When you apply this transformation, which is what we did, that will give you this, but this thing here equals this. Now apply this transformation. This transformation is this transformation means get the whole function here and then stick this negative in front. So when you apply this transformation here, it becomes the function intact. So the function intact here, and then stick a negative in front of it. So this applying this transformation gives us this. Applying this transformation gives us this. So these two are the same. So yeah. So it's an odd function. But just bear in mind that at the moment we just have a gut feeling that this here is the same as this here. Okay, just a gut feeling. Okay, but the overall answer is that this here is an odd function. Yeah, an odd function.